Today I'm going to be going over some different translation practice problems. Let's look at the first problem. This problem states that a triangle on a coordinate plane is translated according to this rule. This rule tells us t -8 for x and y. This is our function rule. This rule tells us and gives us our mapping rule. The mapping rule becomes let us remember that this t represents that we are conducting a translation. The -8 represents what's going to occur to our x coordinate, and the 4 indicates what's going to happen to our y coordinate. That's how we got our mapping rule, x -8 and y +4. This question is asking us to identify what is another way to write this rule. Well, that's exactly what we just did. We just identified that another way to write this function rule is to write a mapping rule. Our mapping rule was C, x -8 and y +4. Let us look at our next problem. This problem states that a rectangle on a coordinate plane is translated 5 units up and 3 units to the left. Well, we know that when we move up or down, that means we have indicated a change in our y coordinate. Well, when we move left or right, that indicates a change to our x coordinate. We have learned that in order to move to the left, we have to have a -3, and in order to move up, we have to have a +5. A positive represents that we are moving up, while negative represents that we are moving to the left. Therefore, our mapping rule would look like x -3 and y +5. Let's see which of our answer choices represents this rule. Answer is C. This is because this mapping rule indicates that x -3 and y +5. Let's look at another type of problem that we might encounter. Sometimes we might be given the mapping rule right away. As you can see the problem states that the rule as a mapping for the translation of a rectangle is x -2 and y +7. Well, we know that when we have an x minus something, we are to move to the left. And we know that when we have a y plus something, we are to move up. Therefore, we want to find a description that describes this translation as a translation to the left 2 units and up 7 units. Let's see which of these represents that translation. A translation of 2 units down and 7 units to the right. A translation of 2 units down and 7 units to the left. A translation of 2 units to the right and 7 units up. A translation of 2 units to the left and 7 units up. Therefore, D is our answer. Let us look at another type of problem. This problem asks, which rule represents the translation from the pre-image parallelogram ABCD to an image parallelogram A', B', C', and D'? Well, the first thing we should do is identify our pre-image. And identify our image. Once again, we know that this is our image because it contains that prime notation, while the pre-image does not. Therefore, we want to find what translation took place from the pre-image to the image. We could do this by identifying a vertex. Let's look at this vertex, vertex C. We can identify that this vertex is located at -5 and -1 in the pre-image. So C is located at -5 and -1. Now, in the image, we can identify that C prime is located at -3 and -2. Now, what we must do is identify what translation occurs for us to get from C to C prime. Let's look at the first answer choice. Answer choice 1 states that we added 1 to X in order to get to C prime. Well, -5 plus 1 is equal to -4. As we can see here, we are looking for -3. Therefore, that is not our answer choice. Let's look at the next option. Here we see that 1 is added. We have already identified that -5 plus 1 is equal to -4 and not -3 as we are looking for. So we can X that one out. C states that we have subtracted -2 from -5. -5 minus 2 is equal to -7. Once again, we have not identified -3. Answer choice D states that we have added 2 to -5 to get 3. Well, if we have -5 and we add 2, we do in fact get -3. Therefore, we take our C, we add 2, and that gives us our C prime vertex. Let's identify if the Y is correct. This function rule tells us that we add 1 to get our Y coordinate of our C prime. Therefore, we would take -1 and add 1 to get 2. This tells us that if we take our C and we add 1, we will find the Y coordinate of our C prime. Therefore, we can identify that this is in fact our function rule for this translation. I want to review another type of problem that we might see. This problem tells us the different vertices of the pre-image and the image. Given these vertices, we are being asked to find the function rule being used to translate this image. Well, the first thing that we should do is actually list out all the different vertices of the pre-image and the image. I'm going to list out all the pre-image vertices in red. We have A, -6, -2, B, -3, -2, C, -3, -6, and D, -6, -6. Now I'm going to list all the image vertices in blue. A prime is equal to 10 and 1. A prime is equal to -10 and 1. B prime is equal to negative 7 and 1. C prime is equal to negative 7 and negative 3. And D prime is equal to negative 10 and negative 3. So now that we have been given those different vertices, we're trying to figure out what rule represents the translation that takes place from the pre-image to the image. Well, in order to identify this, let's go through each answer choice and see if that answer choice matches what is occurring in our translation. Here we see that we have a translation where the x-coordinate is subtracted by 4 and the y-coordinate is added to 3. Well, if we take negative 6 and subtract negative 4, we do in fact get negative 10. If we take negative 2 and add 3, we do in fact get 1. Before we can select this answer choice, we want to go ahead and look at each vertices. So, when we take negative 3 and subtract that by negative 4, we do in fact get negative 7. And when we take negative 2 and add 3, we do in fact get 1. Let's keep checking the vertices just to be sure. When we take negative 3 and subtract negative 4, we do in fact get negative 7. When we take negative 6 and we add 3, we do in fact get negative 3. Let's look at vertex D. We have negative 6 minus 4, which does in fact equal to negative 10, and we do in fact have negative 6 plus 3 equaling to negative 3. Therefore, that is in fact our answer choice. Let's take vertex A for example. What we have just done is we have taken vertex A's x-coordinate in the pre-image and subtracted by 4 to get the vertex A in the image. And we have taken vertex A y-coordinates in the pre-image and added 3 to find our y-coordinate of our vertex A in the image. Let's look at another type of problem that you might see. In this instance, you are being given the information that a triangle ABC is translated according to this mapping rule. The x-coordinate is added by 2 and the y-coordinate is added and the y-coordinate is subtracted by 8. We are being told that if the coordinates of the pre-image of a point B is or are negative 4, negative 5, what is the coordinates of B prime? So what we would do is take that information. B is at coordinates 4 and negative 5, and take our mapping rule to find our B prime. So we would add 2 to 4 to get 6. And we would subtract 8 from negative 5 to get negative 13. As we can see, that gives us our answer choice of D. Sometimes we aren't going to be told our vertices right away, and instead we have to identify what the coordinates of our vertices are given a graph. So we can see here that this question states if a translation 2 and negative 7 has occurred, what are the coordinates of B prime? Well, in order to find the coordinates of B prime, we have to identify the coordinates of B. As we can see here, B is located at 1 and negative 5. So B is located at 1 and negative 5. Well, now we will take our mapping. Now we will take our function rule and apply that to that vertex. So as we can see here, we add 2. So b prime is equal to 1 plus 2. And we subtract -7, so -5 and -7. And that gives us our b prime, which is 3 and -12. We can identify that that is answer choice D. Sometimes we're only given our image and not our pre-image, and we're being asked to work backwards to find our pre-image. This is an example of that type of problem. This problem states the triangle ABC was translated according to the rule, translation, add 4.5 and subtract 6.2 to form the image B prime, to form the image A prime, B prime, C prime. We are being asked to identify what are the coordinates of point C of the pre-image. Well, because we are looking for the coordinates of the pre-image and we are given here the image, we are supposed to work backwards. In order to do this, let's first identify where the vertex C prime is located. Well, it's obvious that C prime is located at -1 and -3. Given that information, we are going to work backwards to identify what the vertex of C in the pre-image is. Well, in order to work backwards, the easiest thing to do is, because we know in this instance we added 5, we would subtract 4.5. And in this instance, because we subtracted, we would add. Remember that the opposite of adding is subtracting, and the opposite of subtracting is adding. The reason that we would do the opposite is once again because instead of going from the pre-image to the image, we are instead going from the image to the pre-image. Right? So what we would do is we would take the coordinates of C prime and we would follow this function rule. So we would take -1 and subtract 4.5 to get -5.5, and we would take -3 and add 6.2 to get 3.2. Let's follow this original function rule just to be sure that we have found the right pre-image vertex coordinates. So what we would do is we would take C 5.5 plus 4.5 and 3.2 minus 6.2. Well, if we take 5.5 and add 4.5, we do in fact get C prime is equal to a -1. And if we take 3.2 and subtract that by 6.2, we do in fact get -3. Therefore, we have successfully gotten our pre-image coordinates in order to arrive at our image coordinates. Therefore, C is our answer.